Okay, welcome back to USC ITP 115, Programming in Python. Today we are going to be talking about files, and in this video we're going to be talking about reading files. So what is a file? You probably work with files every day, but let's define what a file is in terms of computer programming and programming in Python, and what a file is going to be for this course and how we're going to use files in this course. So broadly, abstractly, we can just think of a file as a way of storing a collection of information. And they live on your computer's hard drive or SSD, some way of persisting or keeping information after our program stops. And the reason for that is up until this point, weeks 1 through 9, every time we've been running our program, any data that we have, assigned and we're storing in variables, sits in our RAM, our random access memory. And you can kind of think of that as like having a conversation with your computer, right? Like a verbal in-person conversation with your computer. It's easy to do and it's fast, but after the two of you walk away, there's no record of what you said. And so you can kind of think of a file as like meeting notes, like someone is scribing down, usually deliberately writing down key parts of the meeting so that you can reference it later, maybe even update it after the conversation is over, after the program is over. And there's two main types of files in programming in general: text and binary. Examples of text are what we've been writing this entire course, .py or .py files. You can open them up and a human being can easily read them. We call those human readable. Other types of programming files that you've probably seen every day browsing the web. If you ever open up a web browser and go to your favorite web page and say save page as, and you might be asked, do you want to say this as HTML? And if you ever look at it, hypertext markup, it's got a bunch of angled brackets and it looks kind of weird, but you can still read it. Same thing with cascading style sheets. Just, HTML is like the structure of the web page, and CSS is the style of it. And if you are interested in that sort of thing, ITP offers front end, back end, and full stack web development classes. So definitely check those out. But there's all kinds of text files. There's literally .txt for text files, and you can open a lot of files in a text editor and see just the text, the human readable strings. Then there's a whole other type of file called binary, and those are not meant to be read by a human. They're meant to be read by a computer quickly. Examples of this are your Microsoft Office, Microsoft Word, Microsoft Excel, images, music, multimedia, so JPEGs, PNG, MP3, movies, right? Videos, things that aren't ever meant to be opened up and looked at by a human being. Prose of text file, you can read it. Like you can read and write it as a human being, but it's slow. So pro of text, human readable. Con of text, slow. Pro of binary, fast. Much, much faster for a computer to read and write a file in its native language. Con of it is it's a little bit harder to debug because you can't just open up a binary file as a human being in a text editor and easily see what's wrong with it. In this class, we are going to be using just text files. So you can kind of think of our program as like a middleman between different files, reading and writing files, right? So you might have some data in a file, you want to read it into your Python program and then write it out, maybe in a different format, maybe in a different structure to a different file. And so Python provides the ability to do what we call reading from a file and writing to a file. Right? So we're going to focus on text files in this class because they're cross-platform. So you don't have to have a special version for a Mac or a PC. When you write text, you can, open it, you can write it in Windows and open it up on a Mac and vice versa. So that's what we mean by cross-platform. And they're human readable. Every operating system comes with some sort of basic text editor. Windows has Notepad, Mac has TextEdit, and Linux has tons of free things. And they're great for strings, right? And we can convert numbers to strings and vice versa with typecasting, so we can actually put any type of information into a text file. The only con, right, the only downside to this is speed. So text files, great, easy to debug, but a little bit slow. Binary, very fast, but very hard to debug. So we're just going to focus on text files here. So in this video, we're going to be focused on reading from a file, right? In order to do that, we need a way of, from our .python file, the Python program that we're authoring, right, programming in, we will have a different, right? We'll have a .text file somewhere on our hard drive or SSD that we're going to point to and then open up as and assign to as a variable in Python. And we're going to show the syntax, how to do that on the next slide. But in general, the process is we're going to open the file for reading. So like we'll have some reference to this .text file from our .py file, our program that we're used to writing in PyCharm or whatever editor we're using. Then we're going to read, slurp data in from that .text file, maybe manipulate it, maybe put it out to a different file, maybe put it out to the screen, maybe do some calculations on it. And then finally, right after we're done reading, after we're done accessing the data in that .text file, this is very important, step 3 of 3, close the file. So anytime we open a file, we want to make sure that we close the file when we're done. Okay, so here is the Python command. Just like we've been using print and input, those commands or functions, we now have a new function called open, right? And the parameters for it are a file name. This is the path. This is where it is on your hard drive or SSD. And then the mode, or how do you want to open it, right? So a mode is basically, do you want to read from this file or write to this file? Since we're talking about reading to a file, we're going to use mode R for read, specifying that we want to open up the file at the path file name, right? The full path from the root of our hard drive or SSD to this file name in read mode. Okay, and then this function is going to return, right to left, and we're going to store this reference or this way to get back to this file in a variable, right? In this case, it's file underscore object, obj for object, right? But we can name that anything we want. So file object is actually a new type of file, but it's actually very similar to many other types that we already know, namely lists and strings. So just like we know, or the file types that we know so far are int, float, strings, and lists, right? File object, right? The variable type returned from the open function is a new type of variable called the file object. And you can kind of think of it as a connection or a reference or a link to this text file or whatever, CSV, whatever file that we're specifying with file name, right? And so basically it's a way of converting a file on your hard drive to a Python variable that we can later do stuff with. And so the cool thing about the file object type in Python is that it's a sequence, it's iterable, meaning we can iterate over it, meaning that we can loop over it, the same way that a list or a string or a range of numbers is sequential and iterable and loopable. A file object is. And so what's really cool about this and consistent is we can use the same looping semantics that we've used for looping, for each number in some range of numbers, for each character in some string, for each word in some sentence of words. We can now do that same construct, that same logic for a file. For each line in a file object. Remember, there's an invisible each word here, right? So for each line in some file object, print out the line is how we would read this code, right? Loop through, and if you did this, you would end up looping through every line in that file, okay? Test question, or a very important concept to understand, what's why it gets its own bullet here. Line, the type of variable that line is a string. So when you read a file using this common way of doing it, it's going to treat, it's going to read it line by line, where it reads in that line as one big long string. So even if there are numbers in there, it's going to read it in as a string. If we want to do math on those numbers, we're going to have to remember to typecast it. So this is important. The type of variable line, our loop variable line, is a string containing one line of text from that file. And anytime that we call that open, we want to make sure that when we're done looping over it or accessing it in any way, when we're done near the end of our program, we close the file. And this is really important because if you don't do this, you can get what we call corruption of the file. So if you leave a file open and then you accidentally read or write to it, you can get what's called a corrupt file. It's like leaving a door open and stuff can get in there that you don't necessarily want. So a best practice is close a file as soon as you're done accessing it. You can always open it up again, but you want to make sure that that for every open, there's a corresponding matching close. Okay, so here's a very simple example. Suppose that now in lecture, we need to make sure that we talk about the difference between what's called absolute and relative pathing. In this example, wherever our program is running, and I recommend that we do this for our labs and our assignments too, wherever the .py file that I'm writing this code in that same folder, in that same directory, in PyCharm or whatever editor you're in, you also have a file called words.txt. TXT stands for text. So if you had a file called words.txt, where on one line you had Tommy Trojan, on the next line you had Traveler, and on the third line you had George Tirebiter, then you could open it up for reading using the open command, passing in that file name as a string. Okay, so this is saying, hey, Python, look in the same directory where this program is and find a file name called words.txt, open it up for reading, and then now let me reference it with the variable fin, which stands for file in, meaning this is our input file. Once you have converted a file name on your hard drive or SSD somewhere converted it into a Python variable, fin, of type file object. So it's fin is a variable, it's labeled fin, and it's of type file object. Then you can loop over it the same way you would loop over a string or a list. For every string line of text in this file object, print out the line, and when you're done, close it. And if you ran this code on your computer, the output you would get would look like this. You would have Tommy Trojan, then you have a new line, then you have Traveler, then you have a new line, and you have George Tirebiter, and you have a new line. And you're like, wait a second, I only had 3 lines in my file input. Why do I have these extra new lines in my output? And the reason for that is in the file, when someone was writing this file, they probably hit return. They inserted a new line. And so even though you can't see it in your editor, in your text editor and text edit, and sometimes you can't even see it in PyCharm, it's there. There's a new line character there. And so an easy fix to that, right? Because remember, print's gonna add its own new line. So I'm reading in a new line. Okay, so this is all part of line. And so when I print line, it's going to print that new line character. But then also remember, the default value for the optional parameter of the print end parameter is new line. So print adds its own new line, and I am printing out what I read in, which already had its own new line. So we get the double new lines in our output. An easy fix for that is to simply strip off the leading and trailing white space. Remember, where white space is defined as spaces, tabs, and new lines. And so now on our input, we get rid of those new line characters. Those aren't there anymore. We let print add its own. And so now our output will exactly match our output. Our output will exactly match our input, because now we are stripping off that extra double new line of our input with the strip command. All right, so as an exercise, so suppose that we had a text file that looked like this, and we wanted to output just output to the console. We read in first name, last name, and want to output last name, comma, first name for every line. An easy way of doing that would be write a program, right? We're going to read it, open it up just like we do, loop over it just like we did, strip it, and then we're going to use this other string method that we have used before when we were dealing with strings and lists. Now we're going to split on space. So that is what we're going to split on. And so we're going to, if we split this guy on space, we would get back Carol at one spot in our list and Folt in the next spot in our list, right? And so if we split, right? So now name is a list with two strings in it. Name at index 0 would be the first name. Name at index 1 would be the last name. And now we could print out last name first, comma, space, first name. Then remember to close our file object. Anything that we open, we close, and then we call our main. And I'm going to stop the video here because it's already at 19 minutes. And then I will either make another video or talk about CSV file reading in lecture. All right.